All right, we're back. We're on page 14 of note 17 of Calc C. We're doing polar areas still. We've been doing that for like 2 hours, I feel like. But it takes a little while to get good at this, to get into the flow. And I think we're getting there. So let's see if we can do this. We want to find the common interior of r equals sine of theta, which is a circle centered on the y-axis with a diameter of 1, and r equals cosine of theta, which is a circle centered on the x-axis with a diameter of 1. So we want to find, basically, I'm going to try to trace it. We want this region like this, I suppose, or I know. So how are we going to find this? Well, so I mean, when do these curves intersect? Like you can actually kind of see it. It's definitely at pi over 4. If we set them equal to each other, sine of theta, oh my gosh, what is happening there? Get out. I don't know. That was gross. We would have sine of theta equals cosine of theta. And then like, you can solve this however you want to solve it. I'm going to solve it by thinking about the unit circle. Theta is pi over 4. That's the first time that happens. I really only need to know the first time it happens. So this is occurring at pi over 4. So I'm going to put in the radial line for pi over 4. So I'm building my case for how I'm going to solve this. Become a line. Do it. I mean, I know it's like a wavy line, but I like go one millisecond too early. This is pi over 4. So I think what I can do is think about how polar areas are traced out, right? So you're standing at the origin and you're going to shoot out a laser as you rotate, like you're facing 0. Now you're shooting out your laser and you're hitting the outer edge. So the outer edge you're hitting is actually sine of theta. If I find the area bounded by sine of theta between 0 and pi over 4, it's half of this region. So then I could just double that. Or I could keep going. When I get to pi over 4, I'm shooting the laser out. It's switched. The curve that I'm hitting has switched. So now I'm hitting cosine of theta. So I could go cosine of theta from pi over 4 to pi over 2 and double it. Or I could do both of those and like add them together, but I think that's the weirdest approach. So what I'm going to do is I'm going to do 2 times 1/2 the integral from 0 to pi over 4 of sine of theta squared, sine squared of theta, d theta. Or I think I could do 2 times 1/2, okay, the integral from pi over 4 to pi over 2 of cosine squared of theta. I think these will give me the exact same answer. And I'm going to get, I'll get the exact answer because we can do it geometrically and check. So both of these are going to be the correct answer, I think. Let's switch over to a calculator and see how we did. I don't have a calculator open. Let me see. Calculator. All right, let's switch over to the calculator and see how we did. So you got to make sure that you're in radian mode. I guess I haven't used a calculator since I made the last video, so that's good. I'm going to start a new problem. Calculator. So template for integral. Integral. So it's because it's 2 times 1/2, like I'm not going to write that part. And then we just do sine of t squared t. You can actually do this by hand if you want, I guess. Replace sine squared with 1 minus cosine of 2 theta over 2 and like kind of go for it. Let's do the integral of cosine of t squared t, and we're going from pi over 4 to pi over 2. Same answer. We knew it would be the same answer because we set it up correctly, and that's the key thing. We know what we're doing, so when we set it up, we know that it's going to work out. So what did I get? Pi over 8 minus 1/4. All right, let's write that down. Then, so this is pi over 8 minus 1/4. Let's do a better job of writing a 4. 1/4. How can we do this geometrically? So geometrically, I'm thinking what I would do is, so, I mean, I'm going to do the thing where I do like half of it and double it, like triangle, right? This triangle has a base of 1/2 and a height of 1/2. So it's going to be, so the triangle is 1. Why is this happening to me? All this like weird writing stuff. The triangle, now I can't even write. triangle is 1/2, the base is 1/2, the height is 1/2, so that's 1/8. And then let's do the quarter circle minus the triangle. So I'll use red for the quarter circle. How do I draw a quarter circle? Not like that. Quarter circle is going to be 1/4 of pi times the radius is 1, so pi over 4. What? The radius is 1/2? What am I doing? I was like, oh, good, I got it wrong. 1/2 squared. So this is going to be 1/4 of, this is pi over 16. So I have pi over 16 minus 1/8, but that's only half of it. So I have to double it, which gives me pi over 8 minus 1/4, which is what we got by doing the polar integral. If you have a calculator available and you know the polar integral, way faster, I think. Way faster. Let me move this over so it looks like I did it where I was supposed to. Using a lasso tool. There you go. All right, new question. Find the common interior of r equals cosine theta and r equals 2 sine of theta. Can we, yeah, I guess we can find the intersection of those. So what are we talking about here? We're finding, I'm gonna go around the edge again, the common interior. So this is in both circles. That's what we're looking for, the stuff that's in both circles. So the region I have highlighted is in both of the circles. Now let's think about how polar area gets traced out, right? So this intersection point is key. I need to know the angle that will put me at that intersection point. And then what I want to do is I want to integrate. So you're standing and you're shooting. So the first one that you're hitting is the 2 sine of theta, right? So we have to do 2 separate integrals and add them together. Like there's no clever way to do this, I don't think. So I'm going to do one integral. I'm hitting sine of 2 theta. I'll do that from 0 to whatever this collision point is. Then I will switch over and I will do from the collision point until pi over 2 for the cosine, r equals cosine. That's my plan. So I need to find the collision point, which I think we can do by hand. We do cosine of theta is 2 sine of theta, sine of theta. So 1/2 equals tangent of theta. So I divided both sides by 2 and divided both sides by cosine. So theta is the inverse tangent. So this is part of what you always want to find, like find the first collision point, because after that it gets complicated. Like when, so for example, at pi over 2, the cosine graph is at the origin. So you might think that they're colliding at pi over 2, but they're not, because at pi over 2, your other graph is way up here. So like that's not a theta value where they're in the same place. This is a theta value where they are in the same place at the same time. So I want to use that to my advantage. So that's inverse tangent of 1/2. And then the problem with, it's not a problem. The thing with this problem is like, you don't know if you got it right or not. Like you don't really have a sense of the area of this. I mean, it's probably less than 1/4, because 1/4 would be like this. And maybe it's close to 1/4. Like you'd probably take that and shove it in there. Probably close to 1/4, I'm thinking, but we'll find out. All right, so like I said, I'm gonna go 0 to inverse tangent of 1/2 using the 2 sine of theta. So integral 1/2, the integral 0 to tan inverse of 1/2 of 2 sine theta squared. And then we switch and we do 1/2 the integral from tan inverse of 1/2. So it's like, you gotta mentally plan out your attack and then you just go for it. So that's cosine squared d theta. I think this answer is gonna be close to 1/4. So like just guessing, I'm like taking this region and I'm like morphing it into this square and I'm saying like, I feel that those should be close to each other. So let's see, let's go to the calculator, find out what we got. And then if I'm way off, I'll probably make a bunch of excuses. So I think that I set up the correct integrals though. So 1/2 the integral from 0 to arctan of 1/2 of quantity 2 sine of t squared dt plus 1/2 integral from arctan of 1/2 to pi over 2 of cosine of t, squared dt. Okay, so there's your exact value. I'm going decimal on this because like 0.240. That's really close to 1/4, which maybe is what I said. So 0.240. You want to do that. You want to like look for to estimate it, right? Like, because otherwise, what are you even doing? There's no way to like get a sense of the reasonableness of your answer. So I tried to estimate it based on like squares or rectangles, I should say. If there's not a convenient rectangle, is there a convenient circle that you can put the region inside of? Because like a circle is just as good. It's just as easy to find the area of, basically. This one just felt like that square was like a great choice. So let's see. Next up, find the uncommon interior. Sometimes like I don't even know what I really meant when I wrote these problems. I mean, I think I do here, but so an uncommon, so we got a circle and a limicon. So I think what I'm looking for is a region that is like the entire circle is inside the limicon. So everything inside the circle is also inside the limicon. So that's all common interior. So the only option here would be things inside the limicon. There's no chance I can trace this. Inside, that's just weakness talking, right? Maybe if I hadn't told myself that. You know what it is? It's really hard because I feel like digital artists maybe wear a glove or something that allows them to like smoothly move their hand. Like my palm is just like, I can't do it. It's like stuck to the glass. I think I watched on Disney Plus, there's like a making of Frozen 2 documentary series. Highly recommend. At some point they showed a digital artist and he had like a fingerless glove. And I'm confident that that was so that he can put his palm on there. They don't address it, but I think that's what it was. So, oh, I didn't really finish. And then I have to like cut out this. So I think I can just do the total area of the limicon and then subtract the circle. That's my plan. That's a game plan. So I'm going to do total limicon minus the circle. So how do I get the total limicon? Well, if I go from 0, which is where I start, to right where I start the inner loop, I will have gotten all of this area. So I'm going to do that. So I'm going to go where I start, which is at 0, to where it begins the inner loop. And then I will double that, and that gives me the whole area. So if I do 1 plus 2 cosine of theta equals 0, cosine of theta is -1/2. So theta is 2 pi over 3. And there's more values, but I only need the first one. With polar, you want to take the first one. First thing that happens, just go for it. Don't get greedy. Don't be like, well, what about other values? Nope, you don't want that. So I'm going to do the limicon. So it's going to be 2, 1/2 integral from 0 to 2 pi over 3 of 1 plus 2 cosine theta squared d theta. And then I'm going to subtract the circle. It's a circle that has a radius of 1/2, so you could just like geometry that thing, but I prefer to use a polar. So it's 0 to pi cosine squared theta d theta. Okay, calculator, like, can you do this by hand? Sure. Is it worth it? Probably not. I mean, like, it's definitely worth it. Well, first of all, you might be in a class where they require you to do it by hand, in which case, do it. Right? You got to do what your teacher says. But I just feel like setting these up is more the point. So 0, 2 pi over 3. So there's a 2 times 1/2, but I'm not typing that. And then 1 plus 2 cosine of t squared dt. And then minus 1/2 integral. Doing the full circle here, going 0 to pi. Could go 2 times 1/2, 0 to pi over 2. Totally acceptable. totally gonna work. D squared dt. Do I have a guess as to what this is? So I mean, like, it's kind of, it's like a circle. It's almost a circle that has a radius of 1.5 minus a circle that has a radius of 0.5. So it's like 2.25 minus point. So it's like two. It's almost like 2 pi, I think. And then is it bigger or smaller? I don't really know. Bigger. I think it's bigger than 2 pi. I don't know. Let's see. Yeah, bigger. Okay, so am I right about my estimate? Like, you know what I don't know, which I should know? There's like a whole long list of things that I've wondered over the years and never like gotten really into. It's like, how does the limicon compare to the circle with like the same sort of like center, I guess? You know, like for this, let me go back. So I've written that down. I'm going back, but like the ideal place to look at this would really be on the calculator where I could just like graph it. So what I'm saying is, how does the limicon compare to the circle that has like, I'm saying that this is kind of like the center of the limicon. It doesn't have a center, but like this feels like it because it's like 0 and 3. So 1.5. Draw your circle, right? Radius of 3. Nope, radius of 1.5. I mean, it's clearly bigger, but like, is there an amount by which it's bigger? Like, is there a geometric thing that I could work out? Potentially, I don't know. I never worked it out. Maybe you'll work it out. So I'm gonna end this here because I think we have answered all these questions, and I will be back in the next video to do some more. So I will see you there.